Hudson Robotics provides multiple software packages to control its automated solutions. SoftLinks is our main automation package, used to control multiple robots within a work cell. SoloSoft is a Hudson software program used to control just the Solo. It is used to run protocols specific to the automated pipette. SoloSoft's protocols are built by dragging and dropping commands onto a white space, like so. When a command is dropped, a parameter window for that command is shown. The main commands that we use to build a protocol are getTips, aspirate, dispense, loop and end loop. getTips will direct the unit to grab 1 to 8 tips in a single retrieving motion. Before doing so, it will remove any tips currently on the pipette to either its previous position or a waste area. Aspirate and dispense are liquid movement commands. Aspirate retrieves liquid into tips, and dispense expels liquid from tips. Liquid can be moved from a plate or vessel. Multiple options for both aspirate and dispense are available, including but not limited to mixing, pre-aspirate and post-aspirate of air, changing speed of dispense and adding location offsets at the action point, movement while pipetting, and reading files to figure out the volumes of a plate for cherry picking or hit picking. Additional actions include using the gripper to move labware within the Solo's reachable area, adding time delays, and changing speed of movement. The protocol built for this demo simply mixes 2 columns of liquid between 2 plates and dispenses 25 microliters per plate into 4 output plates. This protocol repeats twice for this demo, and liquid will be dispensed into the first 2 columns of each plate. To increase to a full plate, the outer loop would simply need to run 12 times. Our automation package, SoftLinks, is used to control multiple robots. We simply create a char of commands in order to perform a process. The demo protocol created here is simple. We want to load plates onto the Solo, run the SoloSoft protocol as shown earlier to dispense liquid into plates, then output the plates to either a reader or directly to an output stack. Each one of these processes can be broken down to a series of commands for the unit to run. Loading plates onto the deck. We want to load 4 plates onto the deck. That will require 4 calls of the dispense plate command. Each position is named differently, so we will ask the system to load each spot separately. When you double-click one of these commands, a parameter window will show, allowing you to choose where you'd like to output a plate from and where you'd like to place a plate to. This set of commands will place 4 plates onto the track. While loading plates, the Solo can begin its protocol and start mixing samples. To run 2 things at once, we use a parallel activity. We then call the Solo protocol by specifying it in the run step. Once the 2 processes are complete, we'll want to remove the plates. The first 2 plates can go to an output stack. Since we're using 2 different stack lengths, we'll need to send 2 different commands to output the plates. A move plate step to move it to the output stack, and a return plate step telling the second stack length to place the plate into its output stack. We do this 2 times. At the same time, the Solo is running a cleanup command. The third plate will end up going to a reader, so we'll need to tell the system to act a little differently here. We'll ask the stack links to move the plate to a place where the plate crane, a robotic arm, can grab the plate and load a BMG reader. Once the plate is in position, we'll tell the arm to grab the plate. And then once the reader is loaded, we'll run the sampler protocol. At this point in time, we can output the last plate. Once the reader is done, we'll output this plate as well. The protocol can be collapsed, so it's easier for someone to read. Pretty simple, huh? Once the protocol is complete and plate types are specified for the system, simply hit the play button to run the protocol.